We've seen how we can use the unit circle to find the sine, cos and tan of angles in the first quadrant. So in the first quadrant, if we draw a unit circle radius 1, P is my point xy here. Here's theta. And don't forget P starts there at 0 and goes up to there. So that would be an x value, that would be a y value. And we've worked out that sine of theta in the first quadrant, so angles between 0 and 90. Sine of theta is equal to y over the hypotenuse, which is 1, which is at y. Cos of theta is equal to x, and tan of theta equals opposite over adjacent is y on x. So that's in the first quadrant. Now what happens when we put P in the second quadrant, and how does it relate to sine, cos and tan of those angles? So we're going to look at all 4 quadrants, so let's just work away here. So in the second quadrant, we got P over here. Now how does that correspond to a P over here with a value of theta? So if we make that P xy, this point over here, let's call it P4, and if we make that an angle of theta, then those two y values would be exactly the same, just by a little bit of geometry here. So that's y, and that's y. And if that is equal to x going in that direction, then this is negative x. So here, P4, the coordinates of that point will be negative x, y. And what is the angle that this P4, well, let's just put that negative x, y. What is the angle that point P4 describes? Well, it is the angle, don't forget P starts here. It would go all the way to there and then come back to there. In other words, it would be this angle here. There's my angle described by point P4. So the angle would be all the way around to 180. So go all the way around there and come back theta. Now coming back means going theta in the negative direction. So it'll be 180 minus theta degrees. Okay, so let's just looking at P4 and knowing that the sine of the angle is simply the y coordinate of the point P. Now the y coordinate P4 is here. The y coordinate is simply y. The cos of 180 minus theta is the x coordinate. Now the x coordinate at this point here is negative x compared to that value. And the tan of 180 minus theta is equal to the y coordinate divided by the x. The x in this case happens to be negative x. Now that negative can come out the front of y on x. Alright, so what we're trying to do is to see if we can relate 180 minus theta to just what is theta. So looking at what we've got here, we can see that these two are exactly the same. Sine of theta is y, and the sine of 180 minus theta is y. Now that's pretty powerful. That if you want sine of 180 minus theta, it's going to be exactly the same as sine of theta. The cos of 180 minus theta is the negative of cos of theta, because this is equal to x and the cos of 180. So these two are the negatives of the ones that are in the first quadrant. So the cos of 180 minus theta is equal to minus cos theta. And the tan of 180 minus theta is negative tan theta. Let's look at what happens when we move into the third quadrant. So here's my P in the first quadrant, same as up above there, X, Y, theta. Now if I come through theta there and make this P5, so here's my X and Y, this will be negative Y, this will be negative X, so we've got negative X, negative Y, and the angle is all the way around there, and then we're going to add another theta on. So point P5 has the coordinate negative X, negative Y, and the angle will be 180 degrees plus theta. Maybe if I can move that down a little bit and you can see what's going on with the first one. And you've got sine of 180 plus theta is just equal to my y coordinate, so that's negative y. The cos of 180 plus theta is my x coordinate, so that's negative x. And the tan of 180 plus theta equals my y coordinate divided by my x coordinate, and that's negative divided by negative is a positive. So linking that back, angles in the third quadrant, linking those angles to what happens in the first quadrant, negative y is just negative sine theta, negative x is equal to negative cos theta, and y on x is simply my tan of theta. So in the third quadrant, it looks like tan is, the ratio is going to be exactly the same as that of the first quadrant, and the sine and coses are just the negatives of the sine and coses in the first quadrant. When we go to the fourth quadrant, we've got our first quadrant x, y with an angle of theta. In the fourth quadrant, we'll call that P6. This will be my theta here. So the x coordinate is going to be exactly the same as up there. And if that is positive y up that way, then it must be negative y coming down there. So point P6 with a coordinate of x minus y, what is this angle that P6 describes? It is as though you've gone all the way around to 360 and come back theta. So it'll be 360 minus theta. Or another way of looking at it is just starting at the 0 and going in the negative direction for theta, which is just negative theta degrees. And so what is the sine at P6? What is the sine of 360 minus theta? Sine is the y coordinate, so that's negative y. The cos of 360 minus theta is the x coordinate, so the x, and the tan of 360 minus theta. Now bearing in mind that instead of 360 minus theta we could have just written minus theta here. Tan is the y coordinate divided by the x, so that's negative y over x. Now how does that relate back to the first quadrant? Well, we've got sine 360 is negative y, so it's just equal to negative sine theta. Cos of 360 equals x, and we go back here, x is equal to cos of theta. So the cos of 360 minus theta is exactly the same as cos of theta. Tan is minus y on x, so that's equal to minus tan theta. Okay, so that gives us a way to link angles in any quadrant, either the first quadrant up here, the second quadrant, the third quadrant, or the fourth quadrant. It gives us a way of linking the sine, cos, and tan of angles in second, third, and fourth quadrant back to the sine, cos, and tan of angles in the first quadrant. Now, this is a lot to memorize. When I bring it back, it's a bit easier to memorize. And you don't have to memorize these relationships because there is a way to come up with a way to memorize it. And an acronym again: all stations to central. All stations to central. So starting at the first quadrant, write the A. So in the first quadrant, which is here, all trig ratios are positive. So sine, cos, and tan are all positive. When you get angles here, they are angles between 90 and 180. So this is 0. Between 90 and 180 are angles in the second quadrant. The only one that's positive is sine ratio is positive, and the others are negative. Let's just use shorthand writer. Negative. Third quadrant is down here, so they are angles between 180 and 270 degrees. Tan is positive, and the others are negative. Fourth quadrant, so angles between 270 and 360 degrees. The only one that's positive down there, the cos ratio is positive, and the others are negative. All right, so memorizing that, just CAST, put them down, tells you which of the trig ratios are positive in that quadrant and can relate back to angles in the first quadrant. So this is just a little bit of background as to why that CAST works. I'll come back in the next video and actually show you how to apply this, and then it may become even clearer.